Welcome back, dear students. Today topic in motion in a plane, LAMI'S theorem. So what is LAMI'S theorem? Using LAMI'S theorem, what will derive? Okay. So how to use this LAMI'S theorem? So you can observe on the board. So like one diagram is given. Here two strings are there. Okay. So first string and second string, and middle at a point some load is attached. Here the tension in the first string is say T1, second string is T2. So the load is here 20 Newton, something is given. Okay. Here the last question, find the tension in the first string T1 value how much? Okay. And tension in the string T2 value how much? So the angle between them given. So how to find such type of questions? Okay. By using LAMI'S theorem, easily we can derive. What is LAMI'S theorem? Listen here. If three coplanar forces are acting at a point simultaneously, so that body is in equilibrium, it keeps in equilibrium. Okay. So then the forces are proportional to the sine of the angle between other two forces. For example, here F1 force is there, so it is proportional to the sine of angle between other two forces. Here F2 and F3 you can observe. Okay, so next, like that only F2 force is proportional to the sine angle of, okay, so sine angle between other two forces like F1 and F3. And F3 force if you take, so it is proportional to the sine angle between the other two forces like F2 and F3. Okay, that is gamma. Okay, so like the formula is what? LAMI'S theorem is what? F1 by sine alpha is equal to, okay, F2 by sine beta is equal to F3 by sine gamma. Using this formula, such type of numericals easily we can solve. Okay, in another case also we'll derive. Okay, we'll discuss in this class. Observe here, for example, a pendulum is attached, okay, from a rigid support. Here now this pendulum is pulled aside. What happened that time? By applying some force, this pendulum is pulled aside certain angle theta. So then what happens here? It moves some x displacement, it moves. Okay. At this point, the weight of the body you take mg. Weight of the body acts vertically downward, that is mg. The tension in the string acts upward. Okay, so now this tension T, so I am resolving into two rectangular components. Okay, so one is T cos theta, another one is T sin theta. Okay, here the using this diagram, so we can find out sine function, cos function, tan function, and resultant force. Everything we can find out. Observe here. Here sine function, if you take sine theta equal to what? Opposite side by hypotenuse. Here opposite sign is what? We are applied force. Whatever we applied force. Okay, so this F we can take. Okay, F by hypotenuse is what? The tension in the string. T we can take. Then F equal to what? T sin theta. So like that only cos function. Cos theta equal to adjacent by. Cos theta equal to, if you take adjacent by hypotenuse. Adjacent is what? So this is equal to the mg you can take. So mg by t. Mg equal to t cos theta. So like that only tan function. Tan theta equal to what? Opposite side by adjacent side. Opposite is what? F. Adjacent is what? Mg. So F by mg. F equal to mg tan theta. And from this triangle, so it is very clear, the hypotenuse T equal to under root opposite square plus adjacent square. So that is T equal to opposite side is what? F. F square plus mg square. Okay, so here by comparing time, here x by f we can take. Okay, these are the horizontal lines. X by f equal to the length L by T. Okay, so here we are taking the length tension, so L by T. Okay, and under root L square minus x square by mg we can take. Okay, using these formulas, how to solve the problems, how they'll ask, along with numericals we'll discuss now. On the screen you can observe one question. One question is given on screen, you can observe. If O is at equilibrium, then the values of the tension T1, T2 are x comma y. If 20 newtons is vertically down, then x y r. Then x y. What they are saying here in this question? Okay, so some angle is given. So when some load is attached at point O, here one string is there T2, another string is there T1. What they are saying? So these names are given. T1 is what they are saying, X they are saying, T2 is what they are saying, Y they are saying. Find the X comma Y values. Okay, X comma Y values, how much they are asking. Okay, so first of all, such type of questions, first what to do here, the angles. Okay, angle between the strings we have to calculate. How? Listen here. Already yeah 150 degrees given, 150 degrees given. So what I'll do, so one horizontal line I'll take here. Okay, horizontal line I'll take here. What happened that time, this angle is how much, amma? This O point I'm writing here. Okay, so this angle is how much? 90 degrees. This angle is how much? 90 degrees. Okay, so this angle is 60. Okay, this is 60 means this one also what? 60 degrees only. Okay, so now you can measure here total angles. Okay, so in this circle total angles, okay, how much am I here? 150 plus 60, 210, 210 plus 90, 300 over. Remaining is how much here? Remaining is what? Remaining is what? 60 degrees. Total 360 degrees. Okay, now what we discuss, our LAMI'S theorem. Apply LAMI'S theorem here. Okay, here three forces are there, 1, 2 and 3. Okay, so here alpha, beta, gamma are what? Alpha, beta, gamma. Here tension T1. Okay, this opposite is what? Alpha. Alpha value is almost 60 degrees. Okay, next beta, so T2 function you take, so opposite is how much here? Total this angle, total angle, this one how much is there? 60 plus 90, 150. Why? Because this total angle. Okay, T2 function purpose, total angle, how we are taking total angle. Okay, so like that only, T2 is total angle, 60 plus 90 degrees, 150. Okay, and remaining is what? Okay, so remaining is what? The weight is given, so that is say you gamma you take. Okay, gamma means that one also. Okay, 150 degrees they only given. Okay, here apply the LAMI'S theorem. What is LAMI'S theorem? Using LAMI'S theorem, using LAMI'S theorem, what we can say? F1 by sine alpha. So here T1, T1 by sine alpha. Sine of alpha is how much, here? T1 by sine alpha is how much? 60 degrees is equal to T2 by, so where is T2? T2 by sine, what we said, beta, beta is how much? 150 degrees. And T3 is nothing but weight they given, that is 20 newtons they only given, and the angle they only given how much? 150 degrees. Okay, now the any two you equate. Okay, so here number is there, the weight is there, so that is why I am equating the T1 by sine 60 is equal to, okay, T2. Okay, I'm equating third one, so first and 3 I'm equating. Okay, how much is their weight? 20 by sine 150, sine 150, so we can write sine 180 minus 30 degrees. Okay, here T1 sine 60 as it is I am writing, is equal to 20 by sine 180 minus, okay, 30 means what? Sine 30, sine 30 degrees. Okay, here t1 equal to sine 60 value, we know that root 3 by 2, and 20 sine 30 is how much? 1 by 2. Okay, 1 by 2. Here 2 gets cancelled, therefore what we can take? T1 equal to 20 root 3 newtons. First T1 means nothing but what they are saying, x they are saying na? X value we got how much? 20 root 3 newtons. Now you can equate T2 and, okay, 20 by T2 and T2 by sine 150, and so we'll equate. So we'll see here, we can observe here what is the case. T2 by, equate these two cases, T2 divided by sine 150 is equal to 20 by sine 150. 20 by sine 150. So what happens? Gets cancelled. Sine 150, sine 150. T2 equal to how much? 20 newtons. So this is T2, what they are saying, y. So therefore x and y, okay, how much? 20 root 3 newtons and 20 newtons. Which option is correct? Here on the screen you can observe second option is correct. Okay, so next one you can check on screen. The next one is given. You can observe question. Two light strings of length 4 centimeters and 3 centimeters are tied to a bob of weight 500 grams. The free ends of the strings are tied to pegs in the same horizontal line and separated by 5 centimeters. The ratio of tensions in the longer string to the shorter string is, okay. Here what they are saying in this, okay, so with the help of the two strings, so some load is attached, okay, so the load is how much, the weight is how much? Here 500 grams is given. So like this, 500 grams is attached, 500 grams attached here, okay. Here the length is given, okay, so the separation distance between the two strings how much given? 5 centimeters given, okay. And here the tension, the first string how much they are saying? 4 centimeters, and second string length how much they are saying? 3 centimeters, 5 centimeters and 3 centimeters given. The tension in the first string say T1, tension in the second string is what? T2, okay. So the angles are how much you are taking? Theta 1 and theta 2 I am taking angles, okay. So here this is the point, equilibrium point. So by using LAMI'S theorem, this one also we can find out. So you can observe here the angle, how to calculate the angle. So here I am drawing one horizontal line. So what happens here? This angle is how much? 90 degrees, right? Here also 90 degrees, okay. So here angle between them how much? We don't know, okay. But here this, you say here this one is what? Angle is how much here? Theta 1, and this angle is how much? Theta 2, and this total angle is how much? 90 plus theta 1. This total angle is how much? 90 plus theta 2, 90 plus theta 1, 90 plus theta 2 we can take here, okay. So here the ratio of the longer string to shorter string they are asking, okay. So by LAMI'S theorem, so we'll apply. So T1 by, okay, the opposite Angle sine of angle is how much? T1 by sine of 90 plus theta 1, and T2 equal to what? T2 equal to same sine of 90 plus theta 2. Okay, here the ratio of, okay, T1 to T2, what happens? Sine of 90 plus theta 1 divided by sine of 90 plus theta 2. Okay, sine 90 plus theta, we know that cos theta, right? Cos theta 1 by cos theta 2. Okay, so from figure it is very clear. Okay, cos theta 1, so the adjacent by hypotenuse. Okay, cos function is what? Adjacent by hypotenuse. Okay, so that is 3 by 5 divided by cos theta 2 adjacent by hypotenuse. Okay, so that is 4 by 5. So 5 gets cancelled, therefore T1 by T2, how much ratio? 3 by 4. Which option is correct? On the screen you can observe the second option is correct. Okay, so next problem you can check. A boy is hanging from a horizontal branch of a tree. The tension in the arms will be maximum when the angle between the arms is. Okay, the boy is hanging, okay, with his hands, with the help of hands. Okay, so here we can take the load or weight of the boy is how much we can take here? Mg, or W equal to what? Mg you can take. The tension in the strings, okay, tension in the hands. Okay, the first arm is say both the sides are same only, not T I am taking here by LAMI'S theorem. Okay, so this one also we can find out same like that only. Here I am taking one horizontal line. Here angle, we know that the angle is how much here? 90 degrees. Here also what? 90 degrees only. Okay, here the resultant weight I am taking. Okay, this tension T I am resolving into two rectangular components. So here what we can take here? Resultant we can take here. One is T cos theta, another one is what? T sin theta. This tension T I am resolving into two rectangular components, T sin theta and T cos theta. This is theta. Why? Because theta and theta. Here this tension also resolving into two rectangular components, T sin theta, and here also what? T cos theta plus T cos theta, total 2T cos theta. So now it is very clear from the diagram. So the upward forces are equal to downward forces. Here these, okay, left hand and right hand side, T sin theta, so they are cancelled. So here the upward force are equal to downward forces. Okay, 2T cos theta equal to 2T cos theta equal to, we can take W, we can take, or Mg. Okay, here when is tension is maximum? Okay, so T equal to what? W by 2 cos theta. So when the tension is maximum, for 2 cos theta equal to 1 if you take, so that time what happened? That time tension become maximum. Tension become maximum. 2 cos theta equal to what? 1. Cos theta equal to what? 1 by 2. So in cos function 1 by 2 when we'll get at 60 degrees. Therefore theta equal to how much? 60 degrees. But our answer is not 60 degrees. Why? Because here theta plus theta, total we need 2 theta, we need 2 theta equal to how much? 2 into 60 degrees, that equal to 120 degrees. Okay, so don't confuse, in option 60 degrees also given, 120 degrees also given. So that is why, okay, so check properly. The fourth option 120 degrees is correct. Next problem you can observe on the screen. A body of mass root 3 kilograms is suspended by a string to rigid support. The body is pulled horizontally by a force F until the string makes an angle 30 degrees with the vertical. The value of F and tension in the string are. In this question, which case we can apply? Here the like pendulum type case we can apply. What they are saying here, a body is suspended from a rigid support. Okay, body is suspended from a rigid support. Okay, so then the pull at angle of 30 degrees. Okay, by help of the force they pull at an angle of only how much theta value given, how much 30 degrees given, and your mass of the body, how much mass is attached, so that one also given, root 3 kilograms given, root 3 kilograms given. Okay, so what they are asking, the applied force and tension in the string they are asking. Okay, so your applied force purpose formulas already we taken. So what is the force? F equal to mg tan theta. Applied force formula is what? W F equal to mg tan theta. Here theta given 30 degrees, m is given root 3, and g value here not given. We have to take 9.8 meter per second square. Okay, tan 30 degrees. Okay, so we know that tan 30 value how much? 1 by root 3 tan 30. Here root 3 gets cancelled. Therefore F equal to how much? 9.8 newtons. The force value we got 9.8 newtons. So like that only tension in the string. So tension purpose also I given formula, tension T equal to what amount? So T equal to tension T equal to under root, tension T equal to under root F square plus mg square, F square plus mg square, mg whole square. Okay, here tension T equal to substitute the values. F value just now we got how much? 9.8, 9.8 whole square plus mg. So m is what? The mass is given root 3, and g is what? 9.8 whole square. Here T equal to 9.8 whole square plus root 3 whole square is what? 3 into 9.8 whole square. Here also 9.8 is there, 9.8 whole square is there, here also 9.8 whole square. I am taking common. What happens that time? 9.8 whole square common, 1 plus 3 that is 4. T equal to under root 9.8 whole square, okay, into 2 square that is 4. Okay, so that equal to, you can write how much? 9.8 whole square outside is how much? 9.8, outside the root is 9.8, root 4 outside the root is how much? 2. How much? 9.8 into 2, 19.6. Here tension units, here also what? Newtons only. T equal to how much? 19.6 newtons. Okay, here force value 9.8 newtons and tension is 19.6. Okay, so which option is correct? The second option is correct. So this is a LAMI'S theorem, and a pendulum is suspended from a rigid support. Okay, such type of questions, tension, force, okay, and sometimes angle, they'll ask the questions. So here the next, the after LAMI'S theorem, another topic. Okay, I'll start, so the continuation to this one. Okay, so if you like this video, please, okay, so share to your friends, and don't forget to subscribe, so further more good videos, so you'll get them. Okay, thank you.